Will someone grab the light? Not both of them. Most y'all wanted to do this in the dark.
There's a reason, obviously.
Again, with all the encouragements and niceness. Who does that? Okay, so, and I wrote vectors, and we're not doing that. We're doing parametrics. Okay. Did you just boo me? Yeah, right. Okay, so parametrics we learned yesterday we refreshed our minds on how to graph parametrics and how to eliminate the parameter. Okay, so now we're going to talk about parametrics with calculus. In some ways, parametric equations, doing calculus on parametric equations is actually easier than regular equations. In some ways. So let's talk about the derivative. So if a smooth curve has to be smooth, why? Yeah, it's not going to have a derivative if it's not smooth. Okay, if a smooth curve is given by the equations x equals f of t and y equals g of t. Whoops, sorry. Then the slope of c at some point is dy dx. Now think about this. I'll let you catch up writing and then we'll think. We have x and we have y, and we want to know dy dx. But y and x are both in terms of t. Anyone have an idea what we should do? Okay, you could eliminate the parameter and find the derivative of y. You could. I wouldn't suggest that. Think back to where we're taking a derivative. So think back to chain rule. Oh, good grief. Okay. Let's take the derivative of y. Let's take the derivative of y with respect to t and divide by the derivative of x with respect to t, and we'll get dy dx. And of course, dx dt can't be 0. Okay, the second derivative is kind of weird. So for the second derivative, we have the derivative of the first derivative. That is what the second derivative means. Which is going to be the derivative with respect to t of the function that we just found, dy dx, divided by dx dt. This is something you're likely going to have to commit to memory. When you take the second derivative of the parametric equation, take the derivative of the first derivative, and then divide by dx dt. We're going to come back later and prove that second equation. For now, just accept it. We will talk about it more. Okay, example. Given the parametric equations x equals 2 root t and y equals 3t squared minus 2t, I want to find the first and second derivative. The first derivative is dy dx, and we're just going to find the derivative of y with respect to t, which would be 6t minus 2, over the derivative of x with respect to t, which is going to be so this is like 2t to the 1/2, so we would multiply the 1/2, and then we get t to the negative 1/2. It's just going to be t to the negative 1/2. Be careful with the, like, thinking, oh, it's already on the denominator, that's okay. Are you good? Okay, so this is actually equal to 6t minus 2 times t to the 1/2, which is 6t to the 3/2 minus 2t to the 1/2. Not too bad, right? Okay, second derivative. Okay, it's going to be the derivative of this divided by dx dt. So the derivative of this is going to be what? 6 times 3/2 is 9t to the 1/2 minus t to the negative 1/2 divided by dx dt, which was t to the negative 1/2. We wanted to simplify this. We have 9t to the 1/2 minus t to the negative 1/2 times t to the 1/2, which is going to be 9t minus 1. Who would have ever thought it would be 9t minus 1? You, Brian, you just knew it. You looked at like 9t minus 1. That's what it is. Awesome. Do it. That's funny. Okay, are you good? Not too bad, right? Right, faster. Are you good? Okay, next example. Okay, now we have x equals 4 cosine t, y equals 3 sine t. I want you to write the equation of the tangent line. At t equals 3 pi over 4. So just take a minute to think. What should you do? How should you start?